Hi there, mathematicians. I am here to talk to you about another thing we can do with vectors, which is find the angle between two vectors. And there is a formula for that, one that is pretty easily adapted to 3 dimensions, but we're going to do it just in 2 dimensions. And the formula is, ta-da, the following. This is the formula I use for finding the angle between two vectors, and it's actually not that hard a formula to derive, meaning to come up with from other things we know about vectors. So if that's something that interests you, there's probably 1,002 videos on YouTube that do that for you, but for our purposes here, we're just going to use it. We're just going to practice finding the angle between two vectors, starting with this guy. So here's what a question you might be asked to do might look like. So it says, given the vector v, which is 4i minus j, and the vector w, which is 2i plus 5j, it asks you to find the angle between v and w. So I'm going to go ahead and do that then. And this is the formula I'm going to use. Now, notice that it doesn't have theta isolated. Basically, in order to solve, when we get ready to get our final answer, we're going to have to do the inverse cosine of everything over here. So let's go ahead and get there, see how that works out. So we've got the cosine of theta equals, and then first thing we need is on top, that is the dot product. Okay, so we're going back to dot product here. Dot product of v and w is the product of the horizontal components plus the product of the vertical components. So 4 times 2 plus negative 1 times 5. So 4 times 2 is 8 plus negative 1 times 5, which is negative 5. And so on top, I'm going to have 3. Then we're going to use something else we've already learned how to do, and that is the magnitude. So on the bottom here, we're going to find the magnitude of v and then multiply it by the magnitude of w. Remember, the magnitude is distance. It's a little bit like it's the length. You could think of it as being almost like absolute value, almost like the distance from 0 if we started at 0. But basically, it's Pythagorean theorem. So it's the horizontal component squared plus the vertical component squared, and then we take the square root of that. So the magnitude of v is 4 squared plus negative 1 squared, and that's 16 plus 1, and square root of that is square root of 17. Over here we have 2 squared plus 5 squared. That's 4 plus 25. That's 29. And we take the square root of that. So here's what we have. So now I'm pretty much ready at this point to go ahead and put it in my calculator, because there's not really much of a good reason to simplify it from here first. I might as well just go ahead and get ready to do it in the calculator. So if the cosine of theta is equal to this number, whatever that is, then that means that theta is equal to the inverse cosine of that number. So that's what's going to go in my calculator. So inverse cosine is right above cosine. So let's see if I can put this over to the side so you can see my keystrokes, or at least some of them. I'm going to press second and then cosine for inverse cosine. And then I'm going to put 3 divided by, and I like to be very clear about my order of operations, so I'm putting parentheses around everything in the denominator. Square root of 17. Make sure you close out that radical before multiplying by the next radical, which is square root of 29. We don't want the whole thing under one radical. And then I'm going to close out my denominator, and I am told that the degree, or that theta is 82.23 degrees. This is in degrees. With graphing calculators, it's always a good idea to make sure you know, am I dealing with degrees? Am I dealing with radians? And also, with the question you're being asked, you might be asked for the angle in radians. A lot of times with these, we're asked in degrees, but you better check. So I'm going to call that 82.23 degrees. And that is my angle between those two vectors. Let's think about what those two vectors look like. 4i minus j. So that's 4 horizontal, 1, -1 vertical. So let's say 4i, let's say that's 4 to the right and down 1. So here's my vector, a little bit wavy, I apologize for that, vector v. And vector w up here is 2 horizontal and 5 vertical. So that's 2 positive horizontal, so that means 2 to the right. Let's go about halfway here. That was 4. And about 5 up. Let's say it's about here. Okay, and that's about 2, and that's about 5. I made it look almost like 90 degrees, but the point I'm trying to make here is that what we just finished. Hello there, mathematicians. We are here to talk a little bit more about vectors and things that we tend to do with them and need to be able to do with them. And one of those things is finding the angle between two vectors. And there is a handy-dandy formula for that, and that handy-dandy formula looks like this. Now, this formula is really not that hard to derive, and if you want to search YouTube for a derivation of it, I'm sure you can find several. But for our purposes, we're just going to use it. We're just going to practice finding the angle between two vectors using this formula. Okay, so a couple of things of note. Basically, there are two things I need to already know how to do in order to be able to use this formula. On top, we have a dot product. So I need to know how to find the dot product of two vectors. On the bottom, remember this notation means the magnitude or the length of a vector. And we do that sort of like Pythagorean theorem. So let's get started on that. Let's go ahead and try to find the angle between vectors v and w. The problem says given vector v is 4i minus j and vector w is 2i plus 5j, find the angle between vector v and vector w. Okay, so first thing I need to be able to do on top here, I'm going to say cosine of theta equals, and I'm going to find their dot product. So let's see. The dot product of these two vectors is I multiply the horizontal component, or really the horizontal components, which are also the coefficients of I. So 4 times 2 plus, and then I multiply the vertical components, which is the -1 in front of this j and the 5 in front of this j. So -1 times 5. So that's how I do my dot product. So on top, for the dot product, I'm going to have 8 minus 5, which is 3. Now, in the denominator, the way we find, and let's go ahead and just do these a little bit separately. The way we find a vector's magnitude is we take the square root of the horizontal component squared, 4 squared, plus the vertical component squared. So this is -1 squared. So the magnitude of v here is the square root of 16 plus 1, which is going to be square root of 17. And likewise, the magnitude of w is going to be the square root of 2 squared plus 5 squared. So that is 4 plus 25, so that's 29. So in my denominator, I have the product in the formula of the two magnitudes. There's nothing between there, but that's implied that that's just multiplication. So I'm going to take the magnitude of v and multiply it by the magnitude of w. And I'm just going to go ahead and write those the same way over here, because there's really not much point in simplifying this, because I'm going to have to go to the calculator pretty soon. Now notice we have cosine of theta equals some number. Whenever that's the case, whenever you know the answer for the cosine, but you don't know what angle gave it to you, or sine or tangent or secant or any other ones, that means you're going to have to use an inverse function to sort of work backwards. So in other words, I'm going to end up doing inverse cosine. Let's go ahead and simplify down here and rewrite that so we can see what's going to happen with that. If cosine of theta is this, then that means that theta is the inverse cosine of that same number. That's a 17, kind of hard to see there. So that's what goes in my calculator. All right, so remember, inverse cosine is right on top of cosine. And actually there, I already have it done. Let's do it again. I've got second cosine gives me inverse cosine. And then I'm going to put 3 on top and then divided by, and anytime I have more than one number or expression or anything in my numerator or denominator, I tend to go ahead and put parentheses around the entire numerator or entire denominator. So I'm going to put parentheses around all of this just to double check, just to make sure my calculator observes the order of operations correctly. So I've got square root of 17. Do not forget to close the parentheses. If I had forgotten to close the parentheses that the cursor is flashing on right now, that would be disastrous here, because it would be, I'll show you what it would be in just a second. And do the same thing after the 29, and then I'm closing my parentheses for the entire denominator, and my answer is about 82.23 degrees. Don't forget that when you're working with a graphing calculator, you do need to know, am I in degrees or am I in radians? And a lot of times for these types of problems, you're asked for your answer in degrees, and we are in degrees. But you could be asked in radians. So you need to know not only what is your calculator in, but also what's the problem asking for. And there's my answer. Now, I pointed out that if I forgot this parentheses, or this one, this parenthesis, I guess, I don't know, it would be disastrous, because if I had forgotten that, that would be saying square root of 17, and then instead of coming out of that, that would go ahead and do the square root of 29 up under there. And that's not at all what we were trying to do. So you really want to be careful that you tell your calculator correctly what to do, or else it's not going to do the right thing. All right, that was our first example. So the angle between V and W is 82.23 degrees. All right, let's just go ahead and, well, we'll look at the visual for that on the next one. So here's our next one. Find the angle between V and W when V is I plus 5j and W is 3I minus 4j. So here again is our formula. Cosine of theta is equal to, on the top we have the dot product, and on the bottom we have the product of the two magnitudes of those vectors. Okay, now the dot product on top is going to be 1i, 3i, it's going to be 1 times 3, plus 5 times negative 4. Okay, and in the denominator, the magnitude of V, that's where I do horizontal component squared plus vertical component squared and take the square root. So 1 squared plus 5 squared is square root of 26. And then for W, 3 squared plus negative 4 squared, that's 9 plus 16, so that's square root of 25. So that's actually going to simplify nicely. So on top, I get 3 minus 20, that's negative 17. And in the denominator, this is a 5. Let's go ahead and write that. So I get 5 root 26. There's really not any good reason to simplify that. But when it's something that's such an obvious radical, I probably would just do it. I don't know, to make it visually simpler for me. Okay, so here's what we have, which means that theta is going to be the inverse cosine of this whole mess. So 17 was negative all over 5 root 26. Then I go to my calculator, and I'm going to do inverse cosine of negative 17 divided by 5 root 26. And I don't really need those parentheses, but I'm putting them there. And I get 131.82 degrees. Okay, it's about 131.82 degrees. So let's look at these two visually, these two vectors visually, and see what it is we are finding here. Okay, the angle between them kind of implies that the two of them are tethered together at their initial point. Okay, so for instance, V, it goes, remember it was 1i plus 5j. Let's look at that in component form. That's like saying 1 to the right and 5 up. And this one is 3i minus 4j, which is like 3 to the right and 4 down. All right, so 1 to the right and 5 up for V. Let's call that 1 to the right, and then 1, 2, 3, 4, 5 up. Something like that. So there's V. And this is just a rough sketch, but that's all I really need. 1, for W, I'm going to go 3 to the right and 4 down. 1, 2, 3 to the right. 1, 2, 3, 4. So here's W, and that's what I meant by them being tethered together at their initial point. There's the initial point right there where that arrow is. So what we have just found is we have found the angle between these two, which means across here. We have found that that's 131.82 degrees. So that's what we were looking for, and that's what we found, just sort of in a visual sense. Okay, let's do another one. If you have not already been doing this, please go ahead and pause, try it yourself, and see if you get the same thing I do. Okay, so cosine of theta equals, and on top I need the dot product. Remember that this is the same as 3i plus 0j. So this is 3 times 4, which is 12, plus 0 times 7. 0 times 7 is not going to be anything, so it's just 12. In the denominator, if you only have I or you only have j, then your magnitude is just whichever the one you have. Okay, remember that if we graph our numbers with unit vectors I and j, then this is your horizontal component, this is your vertical component. So this is kind of like it's going 3 out horizontally and stopping. So the length is just 3. We just have one component. So the magnitude of V is 3. That's the magnitude of V. And the magnitude of W, we have two components. We're going to have to do square root of 4 squared plus 7 squared. 4 squared is 16. 7 squared is 49. So that's going to be the square root of 65 for the magnitude of W. So this is what I have, which means that theta is going to be the inverse cosine of 12 over 3 root 65. And yeah, I could simplify that, but there's not a whole lot of a reason to. You're welcome to if you want to. Inverse cosine 12 divided by 3 root 65. I think needing one more closed parentheses, and we get 60 degrees, or 60.25 or 0.26 degrees. So theta is about 60.26 degrees. All right, last example I want to show you is this one. And again, go ahead and pause the video and try it yourself if you want to try and just check that you're doing everything right. This one's going to work out a little bit more interestingly or a little differently. So don't be shocked when it does. All right, so let's take our formula. Cosine of theta equals, on top we have the dot product, which is 3 times 2, which is 6, plus 6 times negative 1, which is negative 6. Okay, so this is what I wanted to show you. If you have 6 plus negative 6 on top, you have 0 on top. Anytime you have a fraction, a 0 in the bottom is a problem. 0 in the bottom is undefined. But 0 on top means 0. So this whole thing is going to equal 0. So basically I've got the cosine of theta equals 0, which means theta equals the inverse cosine of 0. So let's do that in the calculator. What's the inverse cosine of 0? You could think about the unit circle and you would probably know. 90 degrees. The cosine of 90 degrees is 0. That's what we get. Why did I want to show you this one? Because that's the reason that when we want to know if two vectors are orthogonal or perpendicular, which means they meet at a 90-degree angle, what we really want to know is does their dot product come out to be 0? Because that's what's happening on top of this formula. Remember, the formula is Here we go. So if the dot product turns out to be 0, that means you have 0 over whatever. So the whole thing turns out to be 0. And the cosine of theta is 0 when theta is 90 degrees. So that's why we find out what the dot product is and see if it's 0 or not if we want to know if they are orthogonal or if they meet at 90 degrees, because that's what that means. So just wanted to show you that, just to point out how that reinforces what we already know. And I hope this has helped you out. I'm going to give you another couple of videos about vectors, but for now you have a pretty good start on some of the basic things we like to do with vectors. Thanks for coming. Enjoy my other videos. Talk to you later.